Assalamualaikum warahmatullahi wabarakatuh. My name is Nazrul Haikal, Nazrul Zailani, CA20152. This is a video I made for the assignment of self-exploration for one technology. I will be talking about IPSec, or better known as Internet Protocol Security. Internet Protocol Security, or IPSec, is a secure network protocol suite that authenticates and encrypts packets of data to provide secure encrypted communication between two computers over an Internet Protocol network. It is mostly used in virtual private networks, otherwise known as VPNs. Now you might be wondering, what does an IPsec do? Well, there are three things that an IPsec does. IPsec includes protocols for establishing mutual authentication between the agents at the beginning of a session and a negotiation of cryptographic keys to use and encrypt during the session. IPsec can protect data flows between host to host, between a pair of security gateways, or between a security gateway and a host, or better known as network to host. IPsec uses cryptographic security services to protect communications over Internet protocols, or IP networks. As I mentioned before, IPsec is widely used in VPNs. But what is a VPN? Well, a VPN is a virtual private network, and it is an encrypted connection between two or more computers. Virtual private networks, or VPN connections, take place over public networks, but the data exchange over the VPN is still private because it is encrypted. VPNs make it possible to securely access and exchange confidential data over shared network infrastructure, such as the public internet. For instance, when employees are working remotely instead of in the office, like let's say during the COVID disease spread in 2020, they often use VPNs to access corporate files and applications from their workspace. Since many of them cannot access their office physically, they use VPNs to access the files remotely from their homes. And nowadays, many VPNs use the IPsec protocol suite to establish and run these encrypted connections. However, not all VPNs use IPsec. Now you might be wondering, how does IPsec actually work? Well, IPsec connections include these following steps. First step is key exchange. Keys are necessary for encryption. A key is a string of random characters that can be used to lock, or otherwise encrypt and unlock, or decrypt messages. IPsec sets up the keys with a key exchange between the connected device from one end to another, so that each device can decrypt the other device's messages. Next, packet headers and trailers. All the data that is sent over a network is broken down into smaller pieces called packets. Packets contain both a payload, or the actual data being sent, and the headers as well, or the information about that data, so that the computers receiving the packets know what to do with them and how to do it. IPsec adds several headers to the data packets containing authentication and encryption information. IPsec also adds trailers, which go after each packet's payload instead of before. For the authentication process, IPsec provides authentication for each packet, like a stamp of authenticity on a collectible item. This is very important, as this ensures that the packets are from a trusted source and not an attacker or hijacker. For the encryption phase, IPsec encrypts the payloads within each packet, and each packet's IP header, unless the transport mode is used instead of tunnel mode, keeps the data sent over IPsec secure and private. For the transmission phase, encrypted IPsec packets travel across one or more networks to their destination using a transport protocol. At this stage, IPsec traffic differs from regular IP traffic in that it most often uses UDP as its transport protocol rather than TCP. TCP, the Transmission Control Protocol, sets up a dedicated connection between devices and ensures that all packets arrive. whereas the UDP, the User Datagram Protocol, does not set up these dedicated connections. IPSec uses UDP because this allows IPSec packets to go through firewalls. And last but not least, the decryption phase. At the end of the communication, after each network has exchanged their keys, the packets are decrypted using the keys, and the applications, for example a browser, can now use the delivered data. There are two types of protocols that are mainly used in IPSec. They are Authentication Header, AH, and Encapsulating Security Protocol, ESP. The Authentication Header protocol ensures that the data packets are from a trusted source and that the data has not been tampered with in any way or form, like a tamper-proof seal on a consumer product. These headers do not provide any encryption though, and they do not help conceal the data from attackers. This is where the ESP, Encapsulating Security Protocol, comes in. The ESP encrypts the IP header and the payload for each packet unless the transport mode is used, in which case it only encrypts the payload. ESP adds its own header and trailer to each data packet, which securely encrypts the IP header and the data packet. There are two modes of transportation for IPsec, which are transport mode and tunnel mode. In simple terms, transport mode secures data as it travels from one device to another, typically for just a single session. Alternatively, tunnel mode secures the entire data path from point A to point B, regardless of the devices in between. A transport mode in IPsec occurs when two hosts set up a directly connected IPsec VPN connection. For example, this type of circuit might be set up to enable a remote information IT technology support technician to log in to a remote server to do maintenance work. This can happen at any level at anywhere. IPsec transport mode is used in cases where one host needs to interact with another host. The two hosts negotiate the IPsec circuit directly with each other, and the circuit is usually torn down after the session is complete. Whereas tunnel mode usually used between secured network gateways. IPsec tunnel mode enables hosts behind one of the gateways to communicate securely with hosts behind the other gateway. For example, any users of system in an enterprise branch office can securely connect with any systems in the main office if the branch office and main office have secure gateways to act as IPsec proxies for hosts within the respective offices. The IPsec tunnel is established between two gateway hosts, but the tunnel itself carries traffic from any host inside the protected networks. Tunnel mode is useful for setting up a mechanism for protecting all traffic between the two networks from disparate hosts on each end. As a reflection, since IPsec is a protocol used to encrypt and authenticate packets of data, I can relate the security and authentication part of IPsec with PPP, point-to-point protocol, and CHAP, Challenge Handshake Authentication Protocol. For a quick recap, PPP authentication is to validate far-end routers. It sends the username and password of the router to the next router for authentication. If it matches, then authentication happens. This is however, this is dangerous since they use old technology and the passwords are sent in clear text, which makes it easy for hijackers to hijack a network route while PPP authentication is happening. CHAP, however, is an improvement of PPP. It uses a random number instead of username and password, which helps increase the security. And finally, is the generic routing encapsulation, which is also known as GRE. GRE can be related to this since it also uses a tunnel mode. GRE is used when IP packets seem to be sent from one network to another without being passed or treated like IP packets by any intervening routers. So in conclusion, for my opinion, IPsec is a combination of these three terms that I've learned in the past. It continues to improve itself over time, making it more secure for everyone to use. IPsec is the best version of the combined PPP, CHAP, and GRE since it has a high security value, two modes of transportation for every event, and ensures privacy, integrity, and authenticity of information. That is all from me. Thank you so much for watching. Have a good day.